So what we have to do today is go backwards in time and recall synthetic and long division. Now we are not going to be applying long division so much in the remainder of chapter 6, but we are going to be applying synthetic. So what I want you to do for the warm-up is to solve that f of x equation using both long and synthetic division. So going backwards, remembering how to set them up and solve. So using both synthetic and long division, I see that each of these terms end up with a remainder of -8. So over here, I have -3x minus 4, and then my remainder would have given -8 over x minus 3. And here, using synthetic, again, same idea. You would have had one less than the original, so your answer would have been -3x possibly -3x minus 4 minus 8 over x minus 3. So that is what we did in lesson 6-2. Where we divided polynomials by other polynomials. What I want you to do is now take the value 3 and plug it in to our function. So we're going to compare the remainder of -8 to f of 3. So everywhere you have an x, plug in a 3, simplify, the small part of B is sad that we're using a calculator for. So f of 3 is -3 times 3 squared plus 5 times 3 plus 4. So 3 squared is 9. 9 times -3 is -27 plus 15 plus 4. So a -27 plus 15 plus 4 leaves you with a -8. So what I want you to see is the connection between the remainder and the function value. So the focus of today's lesson is how does the remainder in synthetic division compare to the function evaluated at that point. So that is kind of what we're focusing on, and that is what's going to lead into the remainder and factor theorem that we're going to study today. So you should notice that the value of f of 3 is the same as the remainder when you did polynomial division for x minus 3. So that is part of the remainder theorem concept. The remainder theorem concept says that the function evaluated at that divisor's x value is equal to its remainder. So we have some vocab. Our first vocab term is a depressed polynomial. A depressed polynomial is a polynomial that is one. Because I reorganized my notes, so I didn't say it. I just all collapsed on me. So the remainder theorem says if a polynomial p of x is divided by x minus r, the remainder is a constant and p of r is equal to that value. Synthetic substitution is a way of applying the remainder theorem using synthetic division to evaluate a function at x equals r. A depressed polynomial is, like I said, a polynomial that has a degree that is one less than the original. It occurs through division. And then the factor theorem. The factor theorem says that the binomial x minus r is a factor of the polynomial p of x if and only if p of r is equal to 0. So again, binomial x minus r is a factor of the original polynomial if and only if p of r is equal to 0. So if you are given f of x equal to 3x cubed minus 6x squared plus 6x plus 11, they are asked to find f of 3. We can now do this using the remainder theorem. So the remainder theorem simply says that you set this up like in the way that you are going to put 3 in your box. Write out the coefficients of each term. Bring down the first. Multiply, so 3 times 3 is 9. Add, 9 minus 6 is 3. 3 times 3 is 9, plus 1 is 10. 3 times 10 is 30, plus 11 is 44. So what that means is that f of 3 is 44. So instead of having to take 3 and plug it in every time, you can now do synthetics up. So nobody really wants to do 3 cubed, which is 27, times 3, which is 81, and then have to take 6 times 9, which is 54, plus 3, plus 11, which is awesomely writing all on my board to get to that same value. Does that make sense? So like you could plug in 3, you get 44, or do it back. So let's take a minute and do it again for other values. So if I asked you to do it with 2x cubed minus 3x squared minus 17 plus 30, and ask you to find f of 3, our board's not writing, we're just going to slide down. Once again, the value you're looking for goes in your box. You write out your coefficients. Write down the first term, multiply your next terms, and continue going. So bring down your 2. 3 times 2 is 6. 6 minus 3 is 3. 3 times 3 is 9. Negative 17 plus 9 is that negative 8. Negative 24 leads to positive 6. So what that means is that 3, 6 is a point on your graph. So let's try it again. 10, negative 3, and 2. Let's see. So what's nice about having the same function each time is that the top coefficients are going to stay the same, and the only thing you have to worry about changing is the number in your box. So this method is really helpful if you do not have a calculator. This method would be really useful if you did not have a calculator, because you would bring down your 2. 10 times 2 is 20. 20 minus 3 is 17. 17 times 10 is going to give you 170. Minus 17 is going to give you 153. And then times 10 again is 1,530. So 1,560. So again, if you had to do that by taking 10 and cubing it and then squaring it, your numbers are a lot bigger as you add and subtract them together. So using the synthetic method just kind of helps to keep your numbers smaller. So what if we look at negative 3? Now you have negative 3, 2, negative 3, negative 17, and 30. When you plug in negative 3, your remainder is 0. If you get a remainder of 0, that kind of tells you two things. It tells you that negative 3 is an x-intercept, or a root, and it also tells you that x plus 3 is a factor. So it tells you that negative 3, 0 is a root, but that x plus 3 is a factor. And what we're going to work towards today is then the understanding that this becomes 2x squared minus 9x plus 10. And what we're going to do tomorrow is learn how to factor the second part. So today our understanding is, okay, what is x plus 3? X plus 3 is a factor. So this problem here in a factored form becomes that. So when you plug in a number, you get a 0, and it tells you that that is a factor of the original function. So let's look at one more value. We'll look at positive 2. So once again, you get a 0. What's really cool about getting 2 zeros is now I know that x minus 2 is a factor. Its remaining parts are 2x squared plus 1x minus 15. But because I already saw that x plus 3 was a factor, you actually would be able to factor this part again to find that third and final factor because we already know 2 of them. So I can use that to find the third. And then we're going to start using these values to plot points on our graph. So everything like kind of comes full circle and you go back to graphing and factoring and everything together. All right, so then the question is, determine whether x minus 2 is a factor. So instead of being asked to find a value, we're going to go back to where we were with long division and synthetic division, and they're going to say, okay, you have this problem, you want to know if something is a factor of it, and that was like the bonus on your question is, what do you call, x minus 2? Well, x minus 2 is our divisor. If it works, then it is a factor of the numerator. So determine whether x minus 2 is a factor. You would want to set up your synthetic division. And since nothing is grading, I'm just going to cheat and leave them up today. So you would put 2 in your box because it's the opposite of your divisor still. Bring down your values. You see that you get a 0. Because you get a 0, it determines that x minus 2 is a factor, thus making x equals to a root. And like I said, what we're going to do tomorrow is rewrite review factoring, x minus 2 is one factor. These coefficients lead to a remaining result if you take x minus 2 away, and then we're going to factor that again to find our remaining roots. So this is a cubic. It has 3 real zeros, and they end up occurring at 2, -1, and 6, because x squared, x cubed minus 7x squared plus 4x plus 12 factors into that. So a lot of the questions are going to read, determine if something is a factor. So it is your job to set up synthetic and set it up to see if it works. So in example 4, you would have x plus 2. That means in your box is a -2. So in your box is a -2. But rows again. And then across your top is 3, -4, -28, and -16. Bring down your 3. 3 times -2 is -6. Recording's going to work. So once again, I get a remainder of 0. That means that x plus 2 is a factor. So that original becomes x plus 2, 3x squared minus 10x minus 8. So it says determine if it is. The answer is yes. And then determine whether x equals 1 or -1 is a factor. So is it both or neither? Or is it 1? And then if 1 is, what are your remaining? So once again, 1 in the box, 1, -9, -21, -11. So 1 is not a factor. -1 is a factor. So then you have x plus 1, x squared minus 10x minus 11. And then if you want to find your remaining factors, you would factor x squared minus 10x minus 11 as x minus 11, x plus 1. So why did my math go for some no? Oh, it's plus 1. Okay. X plus 1 is a repeated root. See, I can't think now because I'm so mad at my board. X plus 1 is a repeated root, so that means that you get x equals negative 1 twice, so that when you graph it, it's going to hit negative 1 twice, but it's not going to cross it. So, if I wrote x cubed positive, so start low, and then it's going to go to positive 11. So it's going to start low, go high, but at negative 1, it's going to hit